Hello and welcome to my Algebra 1 review series. This video covers Chapter 10, Section 1, titled Exploring Quadratic Graphs. By the end of this video, you will have reviewed recent lessons describing the methods of graphing quadratic equations. You will review the standard form of the quadratic equation, identify the vertex, and graph y equals ax squared and y equals ax squared plus c. And finally, you will review solving a real-world problem. If you'd like me to cover any of these topics in greater detail, please leave a request in the comment section below. Please subscribe to the channel if you like this video and find it to be helpful. Thank you. So before we get started here, we'll look at some definitions. The standard form of a quadratic function. A quadratic function is a function that can be written in the form of ax squared plus bx plus c, where a is not 0. Oh, and the reason it can't be 0 is because if it was, then your a squared term right here, this whole term, would go to 0 and it would no longer be a quadratic. It would be a linear equation, bx plus c. So, in this form is called the standard form of the quadratic function. Examples of it. Quadratic function. Y is equal to 5x squared. Y equals x squared plus 7. Or y equals x squared minus x minus 3. A parabola, okay, the graph of a quadratic function is a U-shaped curve called a parabola. Axis of symmetry. The fold or line that divides a parabola into two matching halves is called the axis of symmetry. And vertex, the highest or lowest point of a parabola, is its vertex, which is on the axis of symmetry. We've been talking about axis of symmetry. Let's see if I can draw one. If we have this parabola, it's going to gotta go like this. Well, not very good. I should probably erase that and try again. Let's try it again. Oh, come on, let's erase it. Let's see if we can get this working here. Erase that and see if I can draw a parabola. Goes down and up. That's better. The axis of symmetry is that line that goes right down here through the middle of this thing. And it would get this point right here, which is what we'd call the vertex. That point right there would be the vertex. And that would be the lowest point in the parabola. If the U was shaped like this, it would be the highest point, and the line would cut it and break it in half, and that'd be the highest point. It would be a facing down parabola. Anyways, so that's that. So objective 1, graphing y equals ax squared. The lowest or highest point of a parabola is its vertex, which is on the axis of symmetry. We just kind of looked at that in the previous slide. It says here, if a, this is important, if a, the ax squared part, the a right here, is greater than 0 in y equals ax squared plus bx plus c, then the parabola opens upward. It's a U shape, right? Let's see if I can get my pen. It's a U shape, right? This is an upward facing parabola. And this is the vertex. Right down here is the vertex. It opens upward. And the vertex is the minimum point. And as you can see, everything, all parts of this parabola are above that line where the vertex is. Okay, this point is the lowest point in the parabola. Now, if a is less than 0, it's a negative a, in y equals ax squared plus bx plus c, the parabola opens downward. So then we've got a parabola opening like this, downward. And the vertex is the maximum point. It's the highest point in the parabola. Okay? And don't forget, they also said it divides the parabola right through the axis of symmetry. So in theory, everything on this side should be exactly the same as what's on this other side here. This is the dividing line right here, the axis of symmetry. My lines aren't very good, or my parabolas, but I think you get the picture. Example 1, identifying a vertex. Identify the vertex of each graph. Tell whether it is a minimum or a maximum. Well, if we go back to our definitions earlier on, it talked about the vertex and where it was and how you found it. First of all, the thing to remember is that the vertex is on the line of symmetry. And what's the line of symmetry? The line of symmetry is that point in this U-shaped parabola. And by the way, all quadratic equations form parabolas. and they're all U-shaped. Some are skinny, some are wide, but they're all U-shaped parabolas, and they either are going to point up or point down, just like you're seeing right now in the video here. They point up and point down, and the vertex is right at the point where the line of symmetry crosses the graph itself, and that is the vertex. So right now, I'm going to look at this one point here. It says that the right there at 1, -2, x equals 1, y equals -2 is the vertex. And if you look at it, it does come down, and it's on that. If I can't draw it probably too well, but it's on the axis of symmetry. And the axis of symmetry is that line around which you could fold the graph in half, and it would match itself on both sides. It would be matching. So the vertex in this graph, in the A graph, is right here at 1, -2, and then B, we're going to look and we find where that line of symmetry is, and that line of symmetry, excuse the squiggly line, but it's right through here, and that means that it puts that dot right here because they are all falling on the integers, right? So right there on -2. X is -2 at this point. And what is y? Y is 2, 4. Okay, 4, right? Here's 4. So this one is -2, 4. That's the vertex. Okay. On this one here, the vertex is 1, -2. Fine. Now, it asks whether is this a minimum or a maximum. Well, if you have a parabola pointing upwards, as this one in A is, the vertex has to be the lowest point on that parabola. You can see it, it's the lowest. And if it's a downward facing parabola, opening down, that means that the vertex is the highest point. Nothing is any higher than that point. Just like on this one in A, nothing is any lower than that point. So identify the vertex of each graph. We did that. And whether it's a minimum or a maximum. So this one here is a minimum. And this one here is a max. Okay? Now, this is check your understanding. You're going to go ahead and do the same thing yourself. Go ahead and look at it. I'll give you some time here. You can look at it. You should be able to figure this out pretty easily. It wants to know the same thing, vertex and minimum, maximum. Okay, so now you know. You've done this. You've stopped. You've thought about it. Now you have your answer in your own heads. So what is it? We know the line of symmetry on graph A falls right here on 4, x equals 4. And the line of symmetry hits this right here at x equals -3 on the B graph. Well, we now, and it doesn't take much to know that right now, the maximum on A is right here where the line of symmetry crosses the line itself, and that happens to be 4 and 3. So the point is 4, 3, which is x equals 4, y equals 3. It is opening down, so that means that this point here is the maximum. Nothing will get any higher than 4, 3 on the A graph. Now when we go to B, we see that the x is the line of symmetry crosses at -3, and that's our down here -3 at the bottom here. The lowest point on this U is at the vertex, and this is an upward facing U, so this is a minimum where A was a maximum. I'll say max over here, and A is a minimum, M-I-N, over here. And what is the point of the vertex? The vertex is -3, -3. It's -3 on X, and it's -3 on Y. It's right here. -3, -3. And it is a minimum on B. And like this, I think we answered it all. Minimum, maximums, the points where the vertex lives. So in example 2, we're going to talk about graphing y equals ax squared, which is a quadratic function. It says you can use the fact that a parabola is symmetric to graph it quickly. And we've talked about that previously, that it's a U and it's either facing up or down, and everything is symmetric about the line of symmetry. First, find the coordinates of the vertex, and then several points of either side of the vertex. It doesn't matter which side you pick, because the other side is going to be reflected across. Then reflect the points across the axis of symmetry. For a function of the form y equals ax squared, that's what we're talking about here, the vertex is at the origin. There's nothing moving it. Okay, nothing moving. It's always at the origin when it's just ax squared. If it was ax squared plus c, it'd be moving it. If it was ax squared plus bx, it would be changing it. That would still put it at the vertex, but it depends on what we're dealing with here. So let's look at this one here. It's just strictly, it says make a table of values and graph the quadratic function y equals 1/2 x squared. So the table is right here, x values, and they're only doing on the positive. Oh, they're only doing the positive side over here. Right here's the positive right here, and here's a positive x, right? We started at 0, right down here at 0. So at 0, the y term it's a 1/2 x squared. So 0 is 0 squared. And take half of 0 squared. Half of 0 squared is 0. And what is the point for x equals 0? Well, when x equals 0, y has to equal 0 because everything is 0 at this point. So this is the vertex right here. And the point of the line of symmetry. So, and like the x, y position is 0, 0. So now let's set x equal 2. So if x equals 2, 2 squared is 4. Half of 4 is 2. So we have 2, 2. X equal 2, y equal 2. So we go out x equals 1. These lines are 2 apart. So this is 2 right here. So x equals 2, y equals 2. That's this point right here. And then when we do 4, we say 4 squared, 16. Half of that is 8. So now the point is 4, 8. So we go out to 4, and we go all the way up here to 8. 2, 4, 6, 8. Here's 8 right there. Well, now you've got half of this parabola. You've got everything on the positive side of the x, right? So now all you do is map it across. You go up to where this point is at 1. You go over to -1. And this is up 1 for the y. This is -1 up for y. You go to 2, because this is 2 right here. Go 2 and -2. So now we go to 4, and 4 is up here to 8. So we go here to -4 and go up 2, 4, 6, 8 and mark our spot. Now we've created the parabola. All you would have to do now is come back through and draw the U-shaped graph, and you have your parabola. So here under example 2, check your understanding. You're going to do this on your own. I've provided a graph and a table to fill in your answers. So go ahead and stop it and the video and fill it out and try it. And you have to draw these on paper. You can't write on your screen. But give it a shot. And when you come back, then we'll go through them together. We'll try to anyway. Okay? Okay, now that you've stopped the video and you've tried it and you've come back, we're going to go ahead and give this a shot. We're going to see what we can come up with. So it wants us to, when we're going to draw a parabola, a quadratic function, we look at it, it's -2 x squared. Okay, so we're going to be dealing with small values, I think. Again, 0, 1, 2, 3, 4. But let's just see what happens with 0, 1, and 2. I don't know. But let's start with 0 right in the middle. Put 0 right here. Okay, and then if we have to change it, we can change it. If we put a 0 here, then what is f of x? If x is 0, f of x is also 0. So that gives us a nice point right here at the origin. Can you see that? Should I change? Maybe I should change to red. How about red? Okay, right here's where we are. Okay, I'll go back to blue to write in the paper. Now if we set this to 1, I'm going to say 1 is right here, 2 is right here, and then -1 and -2. So if it's 1, then what is this? At 1 squared is 1, -2, it's equal to -2. And if x is 2, f of x is equal to 4 squared. 2 squared is 4 times 2 is -8. -8. Okay, so it's going to be the same on the other side too, by the way. It's going to be -2 and -8 because -1 squared is what? Is 1 times -2 is -2. It's going to be the same thing. So what do we have? At 1, we are at -2. So 1 is -2. I said I was going to do red. 1 is -2, and 2 is -8. And I can't get to 8, but I'm going to do it down here somewhere. How's that? That's -8. So our parabola is going to go something like... Oh, should I draw it over again? Let's draw it over again. I have the hardest time drawing these things. Let's try it. Let's try it right here. Got to come down and get that guy there, and then come down and get... Yeah, okay, that's kind of good. And then the same thing on this side, except it's got to be a little more curvy. It's got to be out and down here. Okay, that's not too bad. So the vertex is at 0, 0. 0, 0. It's opening down. The maximum is at 0, 0. It is a downward facing parabola. Okay. And take note that all these y values are all negative. They're all going down. Okay. Okay, example 3, comparing the widths of the parabolas. So now we're going to talk about what makes the parabola U very wide and like a big bowl, and also very pointy like an ink pen or whatever. As you can see, the one on the left is very pointy. So what causes that? Well, the value of the a, the coefficient of the x squared term in the quadratic function, affects the width of the parabola and whether it opens up and down. The graphs below order the quadratic functions f of x equals -4x squared, f of x equals 1/4 x squared, and f of x equals x squared from widest to narrowest. So you can see basically it's the same function. The f of x squared right here, the x squared, and the x squared. This is 1x squared. This is 1/4 x squared. And this one here is 4x squared. All happens to be -4x squared. So when you look at that, now you look at the graphs below, we'll start with the -4x squared. That's the first one that was listed right here, okay? You see that the a term is negative. Since it's negative, that's telling you that this is going to point downward, and it is pointing downward. When the a term is negative, the u of the parabola points down. When it's positive, it points up, just like the other two here. They're pointing up, and you see the a term in both cases is a positive value. And then the next part is how wide is it? We can see that the widest u is the one in the middle here, and it's where the a term is a fractional a term. It's not 1 or greater. It's 1/4, an eighth, a 16th, 90%, whatever you want it to be. It's less than 1, but greater than 0. Has to be greater than 0, and it's less than 1. And that's what makes this get wider. Okay, then if it's if I look at the next one here, I guess we can say that the f of x is x squared. That's the middle one, without the 1/4 or without the 4 times. Well, this is kind of a very common U-shaped parabola. It just kind of goes down and up. Very common. That's where the a term is 1. Okay, everything is just based on the x term. And since it's squared, it's always that same graph. The 4 times, it's opening, you go out 1 on the x, and it's going to go way farther, 4, 8, 16, whatever it is, down, in this case, negative, but it's going to go very fast, so it's going to make it very narrow. Okay, so you have the negative terms making it open up or down, negative or positive, and whether there's the coefficient is greater than 0, makes it skinnier. If it's less than 0, makes it fatter. And that's all based on what a standard parabola would look like, which is A is a 1 term, is 1. And that's basically what you need to know. So just keep that in mind. Negative and positive, down and up, respectively. And fractional A terms makes a wider, fatter parabola, as opposed to integer values greater than 1 make the parabola skinnier, okay, pointier, if you will. So it says of the 3 graphs, f of x equals 1/4 x is the widest, that's the middle graph. F of x equals x squared is kind of in the middle, it's not wider or narrow, or it's not either. Then the negative 4x squared is the narrowest. So ordering them is the 1/4 x squared, and then negative 4x squared is the order on those. Okay, example 3, check your understanding. So they want you to figure this one out on your own, and I'll give you time. You pause the video, and when you come back, we'll go over and come up with these answers. So what they're asking is order the quadratic functions from widest to narrowest, like we just completed in the previous slide. So go ahead and do it. When you come back, we'll continue. Okay, so now that you've done that, let's take a look at these, okay? So I see an x squared term, right here, this one here, x squared. And remember from the last slide, the a value is 1, so that's kind of in the middle. It's going to tell me middle. Although you can have even all greater than 1 or less than 1 and have fatter and narrower graphs. But this is pretty much a standard center of the graph for these types of exercises. Then we have the half x squared, and then we have the 2x squared, negative 2. So what is this telling us? It's telling us x squared is in the middle because there's a half, and they want widest to narrowest. So the 1/2 x squared is over here, and then you have the negative 2x squared is here. Widest, middle, narrowest. Opening up or opening down? Well, they didn't ask for that to give that answer, but now that we're looking at it, you probably didn't do it either, but because we didn't ask it in the problem. Well, which one's opening up? Well, the half x squared is a positive term. It is opening up. X squared, a is positive. It's opening up. X squared here, it's negative 2x squared. It's negative, it's opening down. The vertex is right here, is a maximum. On the other two, the vertex is our minimums. Okay. I think that's good. Okay, objective 2, graphing y equals ax squared plus c. The value of c is the constant term in the quadratic function. Translates the graph up and down. So the y-axis is the axis of symmetry for functions of the form y equals ax squared plus c. So the axis of symmetry is at x equals 0, and the plus c moves, this was saying that the translates the graph up or down. So what it's saying, I'm just going to draw a picture of it here. It's like saying here's our parabola, here's the axis of symmetry, here's the origin, x, negative x, negative x, x. It could be 1, 2, 1, 2, doesn't matter. These are opening up. Okay, this is the x, the y-axis. This is negative y and y right here. So What happens though if you add a c? This is what we saw with just a straight up y equals ax squared. What is it? What happens when you add the c? Well, it takes any value you get for ax squared, no matter what the ax, whatever value you put in for x, you're going to get a value for ax squared, and whatever that is, this is the y-axis we're talking about. The x creates the y output, right? So it's taking and moving it up or down. So if c is positive, let's say it's +1, that says take all of these numbers, whatever you got for y in the beginning half of this function, add 1 to it. So what it ends up doing, I'll draw this one in red, I hope. Let's see if I go in red. It's the same graph. The only difference is now it comes up, it's the same graph. Doesn't change the shape of the graph. It just moves it up a little higher. If this was a 3 and this were a 3 up here, it would like move the graph up to like this. It's the same. I'm trying to draw the same graph, by the way. I'm just showing you that we're going, if it was a negative number and it was down here, the graph would start down here and go up like the same. It wouldn't change the width of the graph, wouldn't change the pointiness of the graph. It wouldn't make a little pointy. It wouldn't change that at all. It's just going to move the graph up and down the y-axis. That's what the c term does. Okay, so now we're going to just, on example 4, we're going to be graphing y equals ax plus c. So we just talked about it, and you can see the picture right there, and that's perfect. There's the picture. So what do? We graphed y equals 2x squared. And they're both identical. Y equals 2x squared. The only difference is we added the 3. Okay? And so when you get the values, then you put, when x is 0, y is 0, on this equation, the 2x squared, but the y equals 3 when x is 0 in this equation. So it's a 3 right here. So you take the red right here. This is where the y would be 0, because you take 0, you're not moving anywhere. Y is, if x is 0, y is 0. But in this other one here, we've taken the 0 from right here, from the first equation, and added 3 to it, and it moved it up 1, 2, 3. Same graph, didn't change the shape of the graph, just changed the position on the y-axis. So the graph of y equals 2x squared plus 3 has the same shape as 2x squared, except it's shifted up. And if this was a negative value, like a -1, it would have moved it down, like we showed in the other one. It moved it down. That's all it would have done. And if you, in order to prove that, you could have done all the numbers. I don't think it's necessary to do the numbers. But you can see, what you can see here is that every number we got for y with the first equation, the other one is 3 higher. So if you put in -2 for the y equals 2x squared, you get 8. If you put it in for the 2x squared plus 3, you get 11. 2 gives you a 5 on this equation. 8, and on the going up the other side of the axis of symmetry, or the line of symmetry, 8 gives you 11, 2 gives you 5, 0 gives you 3. Okay, example 4, check your understanding. Stop the video and try this on your own if you'd like. When you get back, we'll go over them together. We're going to do the same thing we just did on the previous slide. Okay, I'm assuming you've stopped the video and you've tried it, and now we're going to move on. So there are two functions you notice here. One is x squared, y is x squared. The other one is y is x squared minus 4. Well, the base part of each function is x squared. So the graph is going to be identical. We haven't done anything to change the shape of the graph. The only difference is on the second function, y equals x squared minus 4, is you're subtracting 4 from the x squared value, and that's what the y value is. So let's go ahead and run the numbers on the first equation, the x squared. So 0 squared is 0. -1 squared is 1. -2 squared is 4. 1 squared is 1. 2 squared is 4. let's look at this one here now. Y is equal to x squared minus 4. So now 0. When x is 0, y is 0 minus 4 equals negative 4. When x is 1, y is 1 minus 4 equals negative 3. When x is 2, y is 4, and 4 minus 4 is 0. Going the other way, when x is negative 1, y is 1 minus 4, negative 3. And finally, when x is negative 2, y is 4 minus 4 equals 0. So now we can see that the vertex of this of both of these are on the y-axis. That's the numbers we've used are 0, 1. You know, they're identical numbers. There's a U shape, and with the y equals x squared, I guess let me try. I'll use blue for that one. So we have y equals. We started at 0. And the blue is y equals x squared. And when x is when we're 1, okay, it's 1. So it's 1, 1 in both cases. And when x is 2, it's 4. Up here to 4. When x is 2, there. Those are so that's the kind of the graph. It's going to go down like this. Okay, one of the better graphs I've drawn. Not great, but better. Okay, now the difference, I'm going to go to red. Now I'm going to pick up a red pencil. And for the x squared minus 4, it's the exact same graph. I'm going to start at 0, like we did before. Except when your x is 0, y is negative 4. And then when you go to 1, when x is 1, then y is negative 3. So when x is 1, negative 3. And when x is 2, it's 0. And we do the same thing. We map equal over here and over here. And if we look at that graph, if I can draw it kind of the same way, it's almost the same graph with my drawing. But it is. It's just shifted down 4, a negative 4. Okay, the vertex is on the line of symmetry here. It's the y-axis. The graph opens up because in each case our x value, our a value of the a, it's a 1. It's a positive number. So it's opening upward. It's not a negative number. Okay? So it says, think critically. Describe what positive and negative values of C do to the position of the vertex. Well, I think we've talked about it. I think you know. The values, positive and negative, of C raise and lower. Positive raises, negative lowers the position of the vertex. And that's exactly what we did. Okay, example 5. It's a real world problem we're going to solve here, and it's an interesting one. Actually, learning something in physics, you'll see these types of equations. If you stay with mathematics into the future, you're going to see these equations quite a bit. So it's very, very, very common. So it says, in nature, you can model the height of an object moving under the influence of gravity using a quadratic function. So this is we're going to look at gravity moving, have an effect on the object. Okay. As an object falls, its speed continues to increase, ignoring air resistance. The reason why is air resistance would cause it to slow down. And the bigger the object, the more air, the slower it would kind of tend to want to make it, right? So, relative to its weight, by the way. Anyways, you can find the approximate height of a falling object using the function h equals negative 16t squared plus c. Okay, negative 16 is what we use for gravity. Okay, so the height h is in feet and the time is in seconds, and the initial height of the object c is in feet. So this constant, remember how we moved the graph up and down, the vertex? This C here is going to determine how high the ball or what rock or whatever's falling or birds dropping something, how high it is from zero at the moment it starts it's traveling downward. Okay? So suppose you see an eagle flying over a canyon. The eagle is 30 feet above the level of the canyon's edge when it drops a stick from its claws. Okay, it's flying over, and here's the canyon, but just before it gets to into the canyon, there's the edge of the cliff. It drops a stick 30 feet above that cliff, at the top of the cliff. That's what it's saying here. The force of gravity causes the stick to fall toward the earth. And we all know that. The function h equals negative 16t squared plus 30 gives the height of the stick h in feet. Well, they said that the eagle was 30 feet, right here, 30 feet. Oh, is it writing on it? No, yeah, it should be. 30 feet, oh, there it is, 30 feet. And here we're talking about the 30 is the c value in our equation. How high the vertex is shifted from zero, okay? Graph this quadratic function. Well, at zero, here's zero, what is the height of the stick at time equals zero? Well, it has to be 30 feet. The bird is 30 feet above the cliff. The top of the cliff, we're going to call that 0 feet, okay? And it's 30 feet above. So that's, when it lets go, that's time zero. The clock starts running. Where will the stick be in a second, in 2 seconds, in 3 seconds, in 4 seconds as it's falling, getting faster and faster and faster as it's falling through space? Okay, so it'll be 30 feet in the air. And if you look at the equation, it's minus 16t squared plus 30. It'll be 30 feet. In 1 second, how high will the stick be above the ground? Well, this is where it gets fun, because now the height after 1 second is equal to minus 16 1 squared. T minus 16 times t equals 1 squared, then plus the 30. So you see what's happening. We started with a positive 30, and this 16 minus 16 is subtracting, and it's getting closer and closer and closer to the ground as it's subtracting from it. Okay? So after 1 second, if you take 1 second, put 1 in here, you're going to get 16. 1 squared is 1. 1 times negative 16 is 16. 30 minus 16 is 14 feet. And if you look at our little graph, it's after 1 second, here's 1 second in time right here. It's about, after 1 second, it's right here at about 4. It's kind of hard to see it, but they're saying it's right in there somewhere at about 14 feet, a little below the 15 mark. And then after 2 seconds, it would be, here's an interesting point too. After 2 seconds, it will be what? Negative 34 feet. Well, is it going to be in 2 seconds? Is it still going to be moving? No. So in 2 seconds, if you look on our graph right here, I'm going to change colors to this orange maybe. How's that? You look right here, right there. I didn't like orange. Maybe red. Right there. It's just above 2. It's not 2.5 seconds. It's, certainly below 2 seconds. Anyways, it's right there, a little more than 1 second. And in a little more than 1 second, it's actually 1.224 seconds or something like that probably. Or no, not even that, I don't think. Anyways, you can see it. We'd have to run the calculation, put a 2 in here, and solve the height for 0. Well, and I'll just tell you what you do. In order to get that, you've got the equation now. If you want to know exactly what time it will be when it hits the ground, is you said h equal to 0. So you say h or 0. How about that? 0 is the height of the stick is equal to negative 16 t squared. And that didn't come out writing. Oh, my pencil is goofing up again on me. Yep, sorry. There it goes. It does that goofing up thing. Yeah, that's weird how that happens. Let's see if I can try it again. Negative 16t squared, okay, plus 30 feet. Well, the t is going to be, we're going to try to solve for t. So what you're going to do is you're going to subtract 30 from both sides, and then divide by negative 16, and you're going to have is equal to t squared. And then you're going to take the square root of both sides, and, well, without doing it, I don't have my calculator out and stuff, but that's how you solve. You take the square root of both sides, and you'll know exactly the time that that stick will hit the ground. Okay, hopefully that was interesting and fun. Okay, example 5, check your understanding, directions. You're going to do this on your own, but it says, suppose a squirrel is 24 feet above the ground in a tree. She drops an acorn. The function h is minus 16t squared plus 24. It gives the height of the acorn in feet after t amount of seconds. So what they're saying there is, as t moves on, the height is going to change. So we should make I don't know about a little graph. We'll do a little graph, or table rather. It says graph the function. So do this on your own. When you come back, we'll make a table and a graph, and we'll see how it turns out. Okay, now that you've done that, our table is going to be no more than what? A couple terms, because we're not going to go, as we learned from the last example, on the last slide, it doesn't take very long for a stick to fall 30 feet, so it's going to take even less than that for the acorn to fall 24 feet. So we're not going to get very far. So we're going to say this is x, and this is the equation here, right here, is h, the value, right? So when x is 0, or h is what? It's 24, because 16 times 0 squared is 0. It's 0. 1 and 2. Okay? So when t is 1, h is negative 16 plus 24. So that's 8. Right? 24 minus 16 is 8. So in 1 second, the acorn is 8 feet off the ground. It's fallen all 16 feet. Okay? Then, after 2 seconds, 4 times 16, well, that's 64. It's way up there, right? 24, it's minus 40 feet. Okay, well, it's never going to make it to 2 seconds, because when it gets to 0, somewhere between 1 and 2, it's going to hit 0 feet. It's going to be on the ground. So how do we solve that, though? They want us to graph it, so let's try and graph it, see how it turns out. Okay, we're going to say here's the y-axis, here's the x, and this is not going to be very good, by the way, but 1, 2, and we don't care about the backside, and then we don't care about negative numbers, because the ground is right here at 0, y equals 0, and let's say that it said that it's 24 feet, so 5, 10, 15, 20, 25. Okay, so we're going to start. I'll switch to red. Let's do yellow. There we go. So 5, 10, 15, 20, 25. So right a little bit below that is 24 feet, right in there. And after 1 second, 5, 10, we said it was going to be right here at about 8 in 1 second. And then in 2 seconds, it was going to be way down here at like minus 40 somewhere, way down here. I'll put minus 40 down there. So the parabola is going to go like that all the way down, right? But instead of getting way down there, it has to stop right here at 0. Well, where was it when it came through this point? Here was 0. Here was 1. It's not quite a very good graph. Maybe I should not be so hastily drawing those lines on there, because what I want to do is I want to show you that it wants to come through here. It's going to come and get that, and it's going to come out there somewhere, right? Out between 1 and 2. It's kind of what I was trying to show you. Well, the exact value for that, we can calculate what that's going to be. Exactly what time will it hit the ground? Let's do it. So if we say h is equal to minus 16 t squared plus 24. In order to solve this, for what we're looking for, we want to know when the height is 0. Okay, so let's say 0, the height is equal to minus 16 t squared plus 24. So let's solve that equation. So now to solve it, we're going to subtract 24 from both sides. Negative 24 is equal to negative 16 t squared. So the plus negative 24 over here. Okay, we added it in here. Now this is 0. So now we have to get the t by itself. We have to divide by negative 16. So now if we divide both sides by negative 16, we get 24 sixteenths, or I'm going to go a little further, or 6, well, let's see, 6 quarters, or 3 halves. 3 halves equals t squared. And in order to get t squared, then we have to take the square root of both sides. So the square root of t squared is equal to the square root of 3 halves. And that equals about 1.22 feet, or seconds rather. Okay, about 1.25 seconds. After 1.25 seconds, the acorn will hit the ground. It's real fun. I like doing this. So, critical thinking. In example 5 here, why is the domain non-negative values of t? Why are we just drawing from 0 right here, going this way, positive? Well, it's because we might like to be able to, but we cannot go backwards in time. Time only moves forward. You can say what it was a while ago, but you can't move in the physical world into negative time. And that's what it is. All time is positive in the measurement of time. Moving forward is always positive. Positive time movement. Positive time in the real world. In the real world. Okay?